Yes, stuck.
Right. The point at which solid liquid gases are coexist. The point at which the solid liquid gases are coexist at a particular temperature and pressure. So pressure is 4.58 mm of Hg or 610 Pascal. Temperature is 72.15 Kelvin. So it's called a triple point of water. The point at which solid liquid gases are coexist at a particular temperature 273.15 Kelvin and pressure 610 pascals or 4.58 mm of Hg. This point is known as triple point of water. So a triple point of water is obeys Charles law.
So can you repeat the definition, sir?
Huh?
Definition can you repeat, sir?
Definition no need. Just only for only. Okay. Diagram also no need. Just only. Okay, na? So it's not important. Actually, original topic in calorimetric chapter. It obeys Charles law. Because temperature is increases, pressure also increase. Or temperature decreases, pressure also decreases. So temperature increases. Okay? Temperature increases, pressure also increases. So temperature increases, pressure also increases at constant value. Volume constant. So it obeys Charles law. So pressure increases, temperature also increases. The pressure also, temperature increases, pressure also increases. And temperature decreases, pressure also decreases. So most of the curve, two lines are obey Charles law. But the first line is not obey Charles law. So this is called ice line. First line is ice line, steam line, sublimation line. So ice line is, so temperature is increases, pressure decreases. This line does not obey Charles law. Remaining two lines are obey Charles law. So most of the lines are obey Charles law. So triple point of water obeys Charles law. Right? Charles law means P is proportional to T. So pressure is directed to T. Charles law, there are two laws. One is constant pressure, volume proportionality and pressure proportionality.
Sir, mute.
X be the parameter. X be the either like pressure or volume. So X is proportional to T. So X triple is proportional to T triple. So X is either pressure or volume. So X is proportional to T or X is equal to, or that implies X is equal to KT. So that implies X triple. Similarly, X triple equal to K into T triple. So 1, this is a 2. So 1 by 2. So x by x triple is equal to k into t by, so k into t triple. So k cancel, x is equal to x triple, x by x triple t triple into t. So where x is the either pressure or volume. So pressure or volume. This is called triple point of order. This is a relation only for you. So x equal to x is either pressure equal to P pressure by, so temperature, absolute temperature. What is the triple point of order temperature? 272.15. Or x equal to x triple by 272.15 into T. Or, so this is the standard value, triple point of order standard value 272.15 into T. So T and the x value are given. So substitute and either pressure or volume is calculated. So by using this one, x equal to x triple by 273.2.515 into T.
Triple, sir. X triple.
So 272.15 is not T triple, no, sir.
And a 273, not a 272, 273, better.
272.15 it's not a T triple, no, sir.
273.
Sir, what is X triple?
Sir, what is X?
X is any parameter, either pressure or volume. So it obeys Charles' law. Constant volume constant, P proportionality. For example, pressure constant, P proportionality. So where X is either pressure or volume. So depends on given constant, given problem. X is not a pressure, either pressure or volume. X means either pressure or volume. It obeys Charles' law. It obeys Charles' law means, what is Charles' law? There are two laws are there. One is the constant pressure and constant volume. So, for example, volume constant, P proportionality. For example, constant pressure, volume proportionality. Okay, so X is either pressure or volume. So X equal to, X is proportionality, X equal to KT. Same X triple is proportional to T triple. So X is equal to K into T triple. So from 1 and 2, so X by X triple equal to T by T triple. So X equal to T triple by T triple, X triple by T triple into T. So T and X triple values are given. So unknown value, X is calculated. X is either pressure or volume. Maximum either pressure or volume. Right. Figure no need. Definition no need. So formula important. Formula enough.
Sir, the 273.15 is in Kelvin, sir. 273.15, that is Kelvin.
Kelvin.
Okay, sir.
Kelvin. K. Right. Temperature completed. Write down definition as your choice. The point at which solid, liquid, gases are coexist. The point at which the solid, liquid, gases are coexist at a particular temperature and pressure.
Sir, what is the pressure, sir?
Pressure value 610 pascals. Clear? Write down 610 pascals or 4.58 mm of Hg. What is the pressure, sir? Pressure value 610 pascals or 4.58 mm of Hg, millimeter of Hg. Okay, right. Okay. So completed temperature. So problems exercise 2. Problem number 3. So at what temperature on Fahrenheit scale will the reading be doubled? So the reading on Celsius scale, at what temperature on Fahrenheit scale will be the reading is doubled? F equal to 2C, C equal to F by 2, C equal to F by 2, right? So C by 5 is equal to F minus 32 by 9. C by 5 is equal to F, C,
Sir, value Fahrenheit lo ichcharu, sir.
the C value 5 F by 2 into 5 is equal to F minus 32 by 9. Where X is either pressure or volume, right? Where X is either pressure or volume, right? So F by 10 is equal to F minus 32 by 9. 9F is equal to 10F minus 320. So 320 is equal to 10F minus 9F. So F is equal to 320. degree F.
Sir? Sir? So track 1 నుండి ఎక్కువ క్వశ్చన్స్ వస్తాయి సార్, or track 2 will get more questions? So from track 1 we'll get more questions or track 2, sir?
Both are
25.
Not a more and less. 25 track 1, 25 track 2.
Okay, sir.
సార్ ఎగ్జాంపుల్ సమ్స్ అవసరం సార్? ఎగ్జాంపుల్ సమ్స్ చేయాలా?
100%. Not only track 1. Each track, the track 1 and track 2 example sums important. Very, very important. Next one. Fourth problem. Problem number 4. Exercise 2, problem number 4. Accurate Celsius thermometer and Fahrenheit thermometer registered 60 and 141 respectively. C value 60, F value 141. When placed in the same constant temperature enclosure, what is the error in Fahrenheit thermometer?
1 degree.
Fahrenheit thermometer error calculator means Fahrenheit calculated. Okay, Fahrenheit calculator means C minus C by 5. So F minus 32 by 9. So F value calculated. C value 60 by 5 is equal to F minus, for example, this is the F dash is better. F dash minus 32 by 9. 5 1 ja 5.
12, sir.
Sir?
12, sir.
5 1 ja 5.
12,
By
sir.
2. 12 ja. So 12 into 9. 18.
108.
108 equal to f dash minus 32. So f dash equal to 108 plus 32. So f dash is equal to 140. Right. Therefore, delta f is equal to, so f dash, f minus f dash. F dash minus f minus f dash.
1
So
degree.
141 minus 140.
1
So
degree
delta
Fahrenheit.
f is equal to 1 degree f. Error. Right.
Sir, expansion of solids completed now.
Any doubt, Anna? Next, very, very important problem, 10th problem. Eighth one. First 10, next one 8. 10th one, very, very, very important gunshot problem, 10th one. On a hypothetical scale X, the ice point is 40. Is ice point. And steam point. Steam is
120.
120. Next one.
Yes, sir, completed row.
Next, y is equal to y. So next one, x scale. Next one, for another scale y.
Sir, expansion of solids happened, sir. Expansion of solids.
Solid, sir.
Sir.
First one temperature completed, next one solid, sir.
Okay,
So
sir.
we completed all these problems in study hours, sir. So you
Yes,
can
sir.
see expansion of solids.
Yes, sir, all completed problems.
Everything.
Explain again, sir.
Thermometry, we completed everything, sir.
Okay, it's better.
Problem
Right.
explain, the 10th problem explain.
Oh, okay, okay.
10th
Right.
problem explain, sir.
Tell me now.
Sir, 10th problem
10th
explain
problem
again.
explain, sir.
The 10th problem. 10th problem, this one x and y. Yeah?
Yes, sir.
Yes, sir.
So very, very important 10th problem. X is ice point. Tell me ice point.
Sir, ice point 40 degree and
40
steam
degree.
point 120.
Y. Ice point. Minus 30. Steam point
130.
130. Right. X read 50 degrees C. So Y read right. So X minus and any scale minus LFP by UFP minus LFP equal to constant. So X minus lower fixed point is 40, upper fixed point is 120, minus 40 equal to Y minus 30, minus formula minus 30 by, so 130 minus of minus 30. So X value is given 50. 50 minus 40 by 120 minus 40. So Y plus 30 by 130 plus 30.
20 days.
Right. So 10 by 80. 10 by
Correct,
80.
sir. 10 by 80.
10 by 80 equal to y plus 30 by
160.
so, is 1 by 80, 20 ja.
Sir, 82 ja, sir.
81 ja 82 ja.
minus 10.
Cancel.
8 1 8. Yes.
2 ja. Right. So 20 equal to
Y plus 30.
Y is equal to
Minus 10.
10 degrees.
minus 10 degrees. This is the answer.
Sir, they did not mention scale, sir. So only 10 degrees.
So minus 10 degrees C.
Sir, they did not mention scale, sir.
No problem.
So-
See, this is also actually this is the value C now.
Sir, seventh one, sir.
Okay, sir.
Without mentioning C values 50. So no problem.
Sir,
Minus 10.
seventh one, can you see, sir? Seventh one.
Seventh one.
Yeah, sir.
Read problem. Problem read first.
Sir.
A pendulum resistance thermometer reads. Is the problem?
Yeah, sir. That one is. Yeah, sir.
Direct. T is equal to RT minus R naught by 100 minus
I need to use, sir.
R naught into 100. T equal to direct formula.
Sir, 1 second, sir. Sir.
T minus is the formula direct. T is equal to RT minus R naught by R100 minus R naught into 100. A platinum resistance thermometer reads 0 degrees C. R naught equal to 80. All completed again.
Yes, sir.
R naught equal to 7. R naught equal to 80 ohm. Right. Next one R100. Right. The resistor 80 ohm and 100 ohm resistor is R100 equal to 90 ohm. So RT equal to 6 ohm. So T value calculate. So what is the T? So T by 100 equal to RT minus R naught by R100 minus R naught. So T by 100 equal to RT value 86 minus 80 by 90 minus 80. So T by 100 equal to 6 by 10. So 0, 0 cancel. So T is equal to 60.
60 degrees.
60 degrees C. Right. So next chapter is expansion of solids. So part B. So A completed. Part B. Right.
Sir, problems are only concepts, sir. This week, expansion of solids.
Right. Without concept, explain problem.
కాదు సార్ ఆయన ఏం అడుగుతున్నా అంటే ఓన్లీ కాన్సెప్ట్ ఉందా లేకపోతే ప్రాబ్లమ్స్ కూడా ఉన్నాయి ఎక్స్పాన్షన్ ఆఫ్ సాలిడ్స్ లో?
ఇది కూడా ఉన్నాయి ప్రాబ్లమ్స్ దీంట్లో ఉన్నాయి. ఎక్స్పాన్షన్ ఆఫ్ సాలిడ్స్ సెండా పీడిఎఫ్ ఆల్సో సెండా క్వశ్చన్స్ అబ్బాయి అసలు expansion of solids, right? Expansion of solids means actually in solids all atoms or molecules are closely packed. In solids all atoms or molecules are closely packed. For example, this is the solid, liquids, gases. So in a solids all atoms are closely packed. So in liquids is distributed. All molecules are atoms are distributed. In gases is freely distributed. Freely. So freely distributed. So in solids, all atoms or molecules are closely packed. Okay? All atoms or molecules closely packed. Right. So closely packed means are brought to nearer. All molecules are brought to nearer. So it has definite size and shape. Size and shape. Liquids and gases, there is no size and shape. So size and shape depends on container only. But solids has a definite size and shape. So size and shape, so there are three expansions are there. So linear, aerial and cubical expansion. So it has a definite size and shape. Definite size and shape. It has a definite size and shape. So third one, actually, in solids, expansion is very less when compared to liquids and gases. So in expansion of solids, is very less. When compared to solids and liquids and gases. Liquids and gases. And compared to liquids and gases. So this is the expansion of solids is very less because so all molecules or atoms are very closely packed. So for example, this solid expansion is more heat are required. More heat is required. So in solids, so it has more heat. It has more heat is required. More heat is required. Right. So actually, there are three types of expansions. One is linear, so aerial, and cubical expansion. So there are three expansions. One is linear expansion. Linear expansion means along the length. Second one is aerial expansion. Aerial or superficial expansion. superficial expansion. Superficial expansion is along area. Third one is cubical expansion. Cubical expansion along volume. So along volume. So cubical expansion means along volume. Aerial expansion or superficial expansion is along area. So linear expansion means along length. So there are three expansions: linear expansion, aerial expansion, volume expansion. So it has a definite size and shape. All in your atoms, in your solids, all atoms or molecules are closely packed. So it is more heat are required. More heat are required. So because solid expand, so is more heat are required. Is must and should more heat is required. So there are three types of expansions: linear and aerial, and cubical expansions. Right. Right. Next one.
Sir, 1 second, sir.
Expansion of solids ఎప్పుడు దాకా అయిపోతుంది సార్? ఎప్పుడు దాకా అయిపోతుంది సార్ ఎక్స్పాన్షన్ ఆఫ్ సాలిడ్?
ఎప్పుడు దాకా చెప్పాలనా?
కంటిన్యూస్ సార్, కంటిన్యూ.
నెక్స్ట్ వీక్ అంతా ఉంటది
సార్. అంటే ఈ వీక్ ఓన్లీ చిన్న పార్ట్ ఉంటుందా సార్ ఎగ్జామ్ కి?
అంతే కదా, ఈ వీక్ చిన్న పార్ట్. నెక్స్ట్ వీక్
అంటే ఈ రోజు అయిపోతుందా సార్? రేపటికి
సార్ ఎంత టైం
తీసుకోండి సార్. ఇంకా
ఎక్స్ట్రా టైం
తీసుకోండి సార్. అంటే మళ్ళీ రేపే కంప్లీట్ చేసి రేపే
సీనియర్ ఉన్నాడు. up to 5-15 minutes.
Sir, only till introduction of alpha, beta and gamma, sir.
Tomorrow completed a small part. So alpha, beta, gamma, relation between alpha, beta, gamma, relations and variation of density with the temperature. Only one application there. Na? Actually 20 applications are there, but this week only one application.
Okay, sir.
So first, coefficient of linear expansion. Coefficient of linear expansion. So coefficient of linear expansion, coefficient of L expansion, coefficient of cubical expansion. So first one is coefficient of linear expansion. What is the coefficient of linear expansion? Actually, first let us consider a rod of length is L1. Actually, coefficient of linear expansion means this is alpha equal to L2 minus L1 by L1 into T2 minus T1. So what is the definition of coefficient of linear expansion? The ratio of change in length or increase in length per unit length per unit degree rise of temperature. Per unit degree rise of temperature is called coefficient of linear expansion. The ratio of change in length or increase in length per unit length per unit degree rise of temperature is called coefficient of linear expansion. It is denoted by alpha. It is denoted by alpha. Alpha equal to L2 minus L1 by L1 into T2 minus T1. So what is the first one? Proof. Let us consider this is the rod. A rod of length is L1. A rod of length is L1. initial temperature is T1 degrees. Initial temperature T1 degrees. The temperature increases from T1 to T2. From T1 to T2. For example, temperature increases is a T2. Temperature increases, this is the T2. Length also increases. Temperature increases from T1 to T2. Length also increases from L1 to L2. L1 to L2. So this is the increase in length. This is called delta L. Change in length. Difference of length is delta L. Right? The difference of length, change in length is directly proportional to original length and directly proportional to temperature difference. T2 minus T1. So delta L is proportional to L into T2 minus T1. Right. So delta L equal to alpha L into T2 minus T1. So therefore alpha equal to, so delta L by L into T2 minus T1. What is delta L? L2 minus L1. So L2 minus L1 by L1 into, so T2 minus T1. So the change in length is directly proportional to original length and directly proportional to temperature difference. So delta L is proportional to L. Change in length, the difference of length is directly proportional to initial length and directly proportional to temperature difference. So delta L is proportional to L1 into T2 minus T1. So delta L equal to alpha into L1 into T2 minus T1. Alpha, where alpha is the proportional constant, this is called coefficient of linear expansion. Coefficient of linear expansion. So coefficient of linear expansion alpha equal to, so delta L by L into T2 minus T1 or L2 minus L1 by L1 into T2 minus T1 is the coefficient of linear expansion. Okay? Okay, read on first definition. The ratio of,
Sir, alpha is a constant, no sir, here?
Alpha is the proportional constant. Proportional constant. This is called coefficient of linear expansion. Right. The ratio of increase in length. Increase in length. Increase in length. Increase in length of a solid substance. Increase in length. Solid substance. The ratio of increase in length of solid substance per unit degree rise of temperature, per unit degree rise of temperature, per unit degree rise of temperature, per unit degree rise of temperature to its initial length, to its initial length, to its initial length is called, or very simple, the ratio of change in length to original length per unit degree rise of temperature, or anyone. The ratio of change in length to original length per unit degree rise of temperature is called coefficient of linear expansion. It is denoted by alpha. It is denoted by alpha. It is denoted by alpha.
Sir, linear expansion only rods lo avutunda?
Only rod. Solid. Sides means maximum is rods.
Sir, in railway tracks it is observed. Railway tracks lo aitadi sir asla.
To allow the expansion, a small gap
Yes, sir.
Yes, sir.
Thermal expansion ಆಯ್ತದೆ sir.
Two successive railway tracks because of to allow the expansion linearly.
Wires also.
Right. Next one. Tell me radar. So the ratio of change in length to original length per unit degree rise of temperature is called coefficient of linear expansion. It is denoted by alpha. It is denoted by alpha. It is denoted by alpha. Right. Next one, explanation. Let us consider a rod of length is L1. A rod of length is L1. Length is L1. Its initial temperature is T1 degree C. Initial temperature is T1 degree C. It is heated to T2 degree C. It is heated to T2 degree C. It is heated to T2 degree C. The length increases. The length changes or increases from L1 to L2. From L1 to L2.
Sir, once more, can you?
Then increase in length is directly proportional to original length. Directly proportional to original length and directly proportional to temperature difference. The change in length is directly proportional to original length and directly proportional to temperature difference. Right. Delta L proportional to L1, proportional to T2 minus T1, delta L proportional to T2 minus T1. So delta L equal to alpha L1 into T2 minus T1. Alpha equal to delta L by L into T2 minus T1. L means L1, initial length. Right. So L2 minus percentage calculated. So alpha equal to, so delta L by L into delta T. For example, delta L by L into 100 is equal to alpha into delta T into 100. This is in percentage of error. Percentage. Or, so delta alpha equal to L2 minus L1 by L1 into T2 minus T1. So L2 minus L1 is equal to L1 alpha T2 minus T1. So L2 is equal to L1 plus L1 alpha T2 minus T1. So L2 equal to L1 common 1 plus alpha. So T2 minus T1. So final length of the rod. So L2 equal to L1 into 1 plus alpha T2 minus T1. Units. So alpha equal to L2 minus L1 by L1 into T2 minus T1. So change in length and the units also length is same. So cancel, only centigrade. Temperature centigrade. The units is only per centigrade. Centigrade inverse or Kelvin inverse. So dimensional formula theta inverse or K inverse, theta inverse. Okay. Next one, coefficient of aerial expansion. Definition, write down A2 minus A1 by, so A1, this is the beta. Same, no? Same. This is the area. So change it to A.
Sir, down here percentage formula, you did not change A, sir.
Percentage?
Near percentage formula.
Right. Right, same. The ratio of change in area to original area per unit degree rise of temperature. The ratio of change in area to original area, definition write down first. Next one, direct write down, no problem. The ratio of change in area to original area. The ratio of change in area to original area per unit degree rise of temperature. The ratio of change in area to original area per unit degree rise of temperature is called coefficient of aerial expansion. Coefficient of aerial expansion. It is denoted by beta. It is denoted by beta. Right, Rana? Same. So coefficient of aerial expansion. Same model written, cubic expansion also written on. So same V in place of A. The ratio of change in volume to original volume per unit degree rise of temperature is called coefficient of
Can you move aside?
Sir, please move, sir.
Sir, ikkada 2 beta.
Sir, your video is off.
Sir, your video is off, sir.
Phone call. Same written on a cubical expansion also written on a. So tomorrow relation and variation of density.
The relation between all these three, sir.
Alpha, beta, gamma.
Sir,
First
can you
alpha,
move?
Okay, sir.
alpha, beta, beta, gamma, gamma, beta. Just relations. Tomorrow and variation of density. Only one topic completed.
Okay, sir. Thank you, sir.
Okay. Same written on a volume written on a. Same.
Gamma
Yeah.
equals.
The ratio of change in volume to original volume. This is the gamma. V2 minus V1 by V1 into T2 minus T1. The ratio of change in volume to original volume per unit degree rise of temperature.
So in case of A, we have to keep
Beta, gamma, alpha, beta, gamma.
So in place of A, we have to keep B.
Right. In place of B, we in place of either A or L.
So once again.
the ratio of change in volume to or increase in volume to the ratio of change in volume to original volume per unit degree rise of temperature. The ratio of change in volume or increase in volume.
Relation also you say now one.
Relation?
Also you say now only more 10 minutes we have, sir.
No, tomorrow. So another class is there.
So in place of A, what we have to keep, sir? Once you can write and show.
All right.
No, so change the delta A will be delta V.
Yes. Say V in place of L or
V
A.
and gamma.
Delta is same, only V. This is the V. Gamma, V. Right? Okay?
Thank you, sir. Bye, sir.
Okay, Bye, Rana.
Thank you, sir. Bye, sir.